Do you see my presentation?
Yes, it's visible.
Thank you very much. Let's begin. Dear Chair, dear colleagues, hello. My name is Viktor Ilyushin. I'm PhD candidate at National Aviation University, Kyiv, Ukraine, first year. And I'd like to thank you for the opportunity to present the paper on the 7th International Workshop on Computer Modeling and Intelligence Systems in Zaporizhzhia, Ukraine. I am a co-author of the paper with my honorable scientific advisor, Dr. Andrei Goncharenko, professor, as a first author. The paper is dedicated to the research of possible ways to rationalize resources recombination in the area of air transportation technologies, with limitation to the special case of generalized values. The goal was to develop a simple mathematical model able to define optimal recombination of aforesaid resources and applicable to computer simulation. As you can see on the slide, the general idea that we aim to select and generalize two competing air transportation technologies in order to stipulate parameters and criteria of choice within the mathematical model proposed, and then to find a solution in regards with rational recombination of resources used. And this is where I would like to pass the floor to my reputable colleague, Professor Andrei Goncharenko. Shall we, sir?
Thank you very much. Now I can say a few words about that. First of all, let me share my screen. Here's, oh no, sorry. First, this is the option. Now it's visible, and here's, I continue this presentation. According to the formulated problem setting, we are to find next, I would like highlight. So the problem setting, it comprises a few points. Point number one, or item number one, it's formula number one. Actually, it's not formula, just designation. N capital, it designates the amount of transportation work. And we consider it as to the technologies of aviation transportation. Then we consider two competing sources of aviation transportation technologies with their own productivities or capacity, P1 and P2. This is the simplest and obvious provisions, and then we develop formulas 4 and 5 that describe the result A and B. This is an independent case when all this amount of transportation work would be performed by the first type, let's say aircraft or element of technology. We use generalized values as we emphasized at the topic, you see. And then B, it's vice versa, it's the opposite case when all this amount of transportation work or transportation technologies application is performed by the second source of our transportation, formula number 5. So this is the general formulation of the problem, because we have a linear solution, known linear solution, as compared to the known result. Between these 2 points, we have a fragment of this straight line that connects points of just coordinates A and B. And among those solutions, we are to find some optimal recombination, as our PhD student called it, and very specifically and very good term. I hope he will defend it. So, and we seek for optimal recombination of resources 1 and 2, which will be in some intermediate point, but we don't know yet. And we'll consider that on the next posters. But according to our presentation, we would like to emphasize that all the literature survey can be like classified in three engine, for the fuselage, for the skin, and so on and so on. But it lacks, it has a gap, scientific gap of application of uncertainty value. Like in our research, it's symbolized with the entropy, and entropy research is the second portion of the literature survey, is dedicated to the entropy, to the it makes emphasis on the uncertainty situations, but it lacks, it has a gap of, or scientific gap, as I would say, for application, specific application to transportation technologies in air transport, according to our scientific specialty. And the third portion of literature survey of these sources described here, sorry for my not straight highlighting, but I try to be as precise as possible. So the third portion of the literature survey is dedicated to already done applications that can illustrate implementation of these theoretical knowledge. So you see in this triangle, or as it's very fashion style now to call it like triad, we consider some positive and negative effects, but each kind of literature shows the scientific gap of application of other types of literature that we considered, especially known solution, as I already mentioned, linear fragment solution. It was considered before, and it was obtained based upon variational problem solution. And now we used our contender, our PhD student. He made a very good supposition and very clear, very simple, and he got the same solution. And that was the origin of this work and this presentation. I hope it will be very prospective field of application for his possibilities. So this problem, now we try to describe a few notions with the theoretical, this is the poster with theoretical advantages, and we consider it the whole amount of transportation technologies application, like in two components, N1 plus N2, formula number 6. It's also very simple and very obvious that when both sources of air transportation is applied, each of them can perform a portion, so, or a section, like formula 7 and 8 symbolize. For example, N1, small N1, it'll be the amount of such technological items for first kind, and two, it's according to this ratio, the amount over the capacity, it will give n2 small, formula 8. This is the number of sources applied by the second kind, and then summarize them, we get n total. Well, but developing this, we get to formula number 9, 10, 11. This is the final formula, and this one was obtained in literature source in reference 18, formula 5, but absolutely on other scientific speculations and contemplations, suppositions, it was supposed variational problem there, and this is the extremal, the so-called solution of the integral form. Now, optimization technique for n2 like a function of n1, and we consider here just one independent variable, you see, and this is the linear fragment, as I mentioned before, between B and A points, and we see that in our diagrams that illustrate these theoretical notions. Then we need, for optimization technique, we need some extra supposition that there is some positive effect that we would like to maximize during application or implementation of air transportation technologies. And there is a developmental portion and regressive portion, and difference between them, it's easily recognized as a profit for the difference between income and expenses. But in our terms, it can be interpreted in all different ways. But now let's consider that both developmental and regressive components have their own models. Here it's also not so difficult, 13 and 14. And then after finding the final maximal result for positive value, we may consider the preferability of these types of technology sources applied. So for this purpose, we use the measure of uncertainty of this situation, operational situation, like traditional entropy, formula number 20, and this function, formula number 19, is composed with two multipliers. First portion, it's the relative level of certainty or uncertainty, and the second, it's like dominating or prevailing factor, because you see we consider here preferences of the so-called, in quotation marks, good kind and bad kind, something good and something bad. We compare that, and then in relation to the absolute difference between these preferences functions, formula 21, which is obtained based upon subjective analysis theory. And a result can be illustrated in the next section, experiments and results. We did computer modeling. So here's the example of our segment of a straight line. It symbolizes the simplest solution. And supposing productivity or capacity of two sources of aviation transport technologies, like in the ratio 1/2, so 1/2. So we get the solution like number of these sources, vice versa, 1 to 50, 50 items to 100. So the same proportion, but vice versa. Then the problem is here to find, let me show you with the marker red color, to find this found optimal point of recombination between these resources. You see, it's for 58, number 58 of resources, first type, and the second type, it means 21. So how did we get this solution? It may be shown with the next slide. Here we have our positive effect, red line, and it's built here, and we get maximal value at the independent variable n1, number of first type, 58, which leaves just exactly 21 amount for the second type. And actually this magenta line and red line, it's the same positive effect of technology application by build. Like in first case, it's depending on independent variable n1, and second is it's like a phase diagram of the phase variable n2, which is the function of independent variable n1, which corresponds to the theoretical result presented here, formula number 11. This one, it's here. And then finding this value was because maximizing the positive effect. Talking of the uncertainty situation, we may emphasize that some managerial or governing subject may be interested in developing just separately first kind progression and positive values and the second value, and comparing that with the help of traditional entropy. It's a blue line, doesn't show us what is the relative certainty of the situation we have at the value of 17, number 1, 17, and then 73. But the proposed relative function, like a hybrid function, which comprises directions and relative value of uncertainty, shows exactly that first type, around 17 items of the first kind, it was the negative certainty, which means, so the uncertainty at this point means much better situation than this certainty. Vice versa, 73 means good certainty, but traditional entropy again doesn't show that. And one more thing, this value of entropy of this level, we have two more points, and they also specified for the good certainty, which can be traced by vertical lines. Sorry, MATCAD cannot project more than two levels for independent variables. So you see, this is actually the core of the problem. And for the final word, I'd like to ask our inventor, our PhD student, Victor Ilyushin, to say a few sentences by the end of this presentation. Please, are you here, Victor? Can you hear me? Can you conclude? So computer modeling, it in aviation transport technologies, so we model elements of resources, and it's particularly important to consider here computational intelligence, because it helps us to discover some unknown effects. And for further research, we would suggest to investigate dynamics of the system. All right, thank you very much for your attention. Now we may stop the presentation. See you again. Goodbye.